Now at the end, let's summarize the requirements we noted down and how did we solve them. For the first requirements of nearby drivers, we brainstormed around the communication protocol drivers can use. We realized that these are a lot of DB calls if we go by the brute force approach. So what we did was to store all these requests in a temporary place and then just dump those requests to our main database in a batch after 15 seconds instead of 3 seconds. However, the driver's locations will keep getting updated in our temporary cache storage every 3 seconds. Then, for customer and a driver to match, we thought about how the matching mechanism would work. And out of 500 drivers, how can we request a ride to the most nearby drivers to the customer? For this, we divided our map into grids. We noticed that instead of searching for drivers, we can search for the nearby grids and then return the drivers from them. Since we'll again have a lot of drivers, we further extended our matching mechanism to return only the top 10 drivers. We also added a custom pagination thing here so that if any of those 10 drivers don't return the request, we can further find the next 10 drivers and so on. For tracking and completing the trip, we can do a simple polling on a customer's device. We haven't discussed the rating and analytics part because they are fairly straightforward, and analytics and monitoring is something that is very common across systems. So we can send events in a Kafka consumer and consume them through the monitoring platform. So we can track the customer events through a Kafka queue and have them consumed in the ML or monitoring platform as and when required. For the non-functional requirements, we discussed how to store our grid tree onto multiple servers and scale it for the storage. We also used a pub/sub pattern so that only a few drivers are subscribed to a customer at a time. We discussed about the master replica architecture and how even despite failures we will be able to recover from them, making our service highly available. We made various optimizations around our queries, resulting in a fast enough trip match between a customer and a driver. Since we needed strong consistency, we divided our data onto multiple shards and used aggregation servers on top of them so that our customer does not directly interact with the shard and yet rather interacts with the aggregation server and is always returned a consistent result. So these were just some of the requirements and we only solved this problem in one particular way. Just remember that system design is very open-minded. So if you have other ways to solve this, that is also fine. The focus is always on the approach you take to solve these problems and not at the actual output. So I would recommend you to take a pen and paper and try solving this problem again from scratch without referring to the slides. With that, I'll see you in the next case study.